All right. Welcome to our last lesson of Unit 2, Solving Equations Graphically. Today's date is Tuesday, December 1st, 2020. As we said, for solving equations graphically, our objective today is to do what? Go for it, Leo. There it is. So you are responsible for 4 functions. Because you haven't done exponential in a while, I will be reviewing that first. I assume you know how to do linear, but I'll just do one review problem. And I'll do a little bit of review with quadratic and absolute value as well. All right, so let's talk about exponential functions because it's the one that you have seen the longest ago. Oh, is that Sam? Is she here?
Hi.
Hello. Welcome. This is the last lesson of our unit. So a parent function, 2 to the power of x. What does that look like? Again, if you don't know, you can always make a table. But generally speaking, if you plug in the power of 0, anything to the power of 0, everyone will shout out is? Anything to the power of 0 is? Is it 0 or is it 1? It's 1. Does anyone know why? 2 0 times. Wouldn't that be 0? I don't know. It's 1. Here, let me show you a cool little pattern that maybe will help you remember. Does everyone agree that 2 to the power of 1 is 2? Do you agree that 2 to the power of 2 is 4? 2 to the power of 3 is 8, etc., etc.? Okay, then let's kind of skip over 2 to the power of 0. 2 to the power of negative 1, using rules of exponents, is 1 over 2. 1 over 2 to the power of 1, to be exact. And then 2 to the power of negative 2 is 1 over 4, etc., and it goes down and on forever and ever. So the only number that makes sense in order to divide by 2, get from the next number to the next number, divide by 2, to keep this pattern consistent of dividing by 2, dividing by 2. In order to get from here to here, I also must divide by 2. 1. And it works for any sort of base that you have. 3 to the power of 1, 3 to 4 to the power of 1, anything that you have. No matter what happens, there's always a central number. Any number to the power of 0 is always 1 to keep our patterns consistent. And that's generally the way that all rules of mathematics work. How can we keep our rules as consistent as possible, as consistent so that they're consistent 100% of the time? And the answer is anything to the power of 0 is 1. So if I plug in 0 on the x coordinate, the height is 1. And that this number, this point right here, will happen no matter what your base is. And I should let you know that in terms of our quiz and test that's coming up the next few days, I'm never going to have a base other than 2. So this number is always going to be 2. But if I was quizzing you guys on just an exponential unit, I would definitely change this to other numbers. Regardless of your base, if it's 2, 3, 5, whatever, this point 0, 1 will always be on your graph of your parent function. And then the next thing you do is go right 1 upward. Why? You really are going right 1 and up to the height of 2. If I was having something like 3 to the power of x, I would go right 1 up to the height of 3. But because it's a base of 2 over here, a base of 2, our y coordinate is 2 for our next point. And then the way that you figure out the next points is you keep doubling. So this height is 2, you double that, 4, you double that, you double it, and you keep doubling it and doubling it. That's an exponential function. If you do the reverse of that and you do half of each of these points, then you'd say half, 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 etc., etc. You'd never actually touch the height of 0, but you'd approach it. You'd have what's called an asymptote. So with these 2 points, you should be able to roughly sketch this line. That comes out through here. There is your parent function that you need to have down. So you will always have the point 0, 1, and you'll always have the point 1, 2, because I'm making the base the same. Those 2 points are always going to be the same steps over and over again. There's this thing called an asymptote. I'll write it down. Asymptote. It's spelled weird, but it's pronounced asymptote. The P is silent. Pretend that the P is not there and you will pronounce it correctly. Asymptote. I can actually draw the asymptote too if you'd like. So the asymptote is just this horizontal line that is the x-axis. This red line is the asymptote. I get closer and closer to this line without ever touching it. This asymptote will shift though. It will change depending on what your general function turns into. So in our scaffolded lesson last time, we talked about parent functions and then general functions. I'm following with the same format. The general function for us, it's a modified. I put a little asterisk here because technically you could have other things in here too. I could have a change of base. I could have that base instead of 2, I could be 3. But I'm making it as simple as possible because this is what I'm requiring for the quiz and the test. It's definitely going to be 2. There's only going to be an h and a k. That's all I care about. H. Does anyone remember what we called h yesterday? What type of shift was it? And if you don't know the exact name, you can say up, down, left, right, that type of shift. Yeah, quick. Beverly? It is the left, right shift. Left, right. I ran out of room there. Left slash right shift. That is called the horizontal shift. And therefore, K is the other type of shift, which is the vertical shift. That's the up, down shift. Which is pretty interesting because it's easy then, right? If it's always these 2 points and all I have to do is move them both left and right, then both up and down, there's no sort of vertical stretch that I have to worry about. All you have to do is move them. I will have a note here. Whenever you have K will move your value of your asymptote. So if you move up and down, this red line, this asymptote moves with it. Something to keep in mind. All right, and then again, shift both points for both H and both K. Both of these points get moved with both of these values of H and K. All right, so let's try an example. And I should come down here to command 1. Why is it doing that? Okay, there we go. So 2 to the power of x minus 3 and then minus 2. So let's first graph 2 to the power of x, 2 to the power of x. I'll say y is equal to 2 to the power of x. Then I'll graph y is equal to 2 to the power of x minus 3. And then I'll graph y is equal to 2 to the power of x minus 3, then minus 2. What do these look like? And I realize that this last one probably doesn't fit on our graph, does it? Oh well. All right, 2 to the power of x. Everyone graph it right now because I've already done it for you. That's our parent function, 2 to the power of x. Regraph it. Show me that you know what you're doing. Hopefully you had a point at 0, 1 and 1, 2, and then you made the right shape. More or less. It should be a little bit more curvy, not a straight line. All right. Someone help me now. What am I going to do to both of these points now that I have this x minus 3 for the exponents? Beverly? Shift left how many? 3. Really close, but remember, whenever you have something next to the x, this would kind of be like in the parentheses, you do the opposite. So instead of left, you're going to go right 3. So this point used to be here at 0, 1, but I'm going to move 1, 2, 3 right. And our new spot is here at 3, 1. Which means our next point is 4, 2. And again, go ahead and sketch that line. It goes off the graph. And it gets, man, my line over here is pretty terrible, but it gets closer and closer to this line without ever touching it. And then finally, our equation 2 to the power of x minus 3 minus 2. What do I do to those 2 points now? Subtracting 2. That's the value of k in our general formula up here. K. What's going to happen? Yeah, Ellery? Down 2, yeah. So it's a little bit off the graph, but this point used to be here at 3, 1. It's going to go down 2, 1, 2, went off the graph, and it's going to be down right there at 3, -1. This point was at 4, 2. I'm going to go down 2, 1, 2, and it's going to be at the coordinate 4, 0, and that's our new graph. And please note that your asymptote also moved down 2 as well. So your asymptote is going to look like this. All right, you now know how to graph an exponential function. Can everyone give me a fist of 5? How well are you following the exponential graphs so far? In 3, 5, 4, 4, 5, 4, 4, 5, 3. All right. Does anyone have any questions before we move on to the examples? Yeah, Ellie? It's against the asymptote now, not against 0. Yeah. And again, the easiest way to pronounce this is put your thumb over the piece. Asymptote. Yeah. All right, example number 2. And this is the version that Khan Academy has too. So let me zoom in here so we can see what we're talking about. So we're going to say f of x is equal to 2 to the power of x all over x plus 1. That is a disgustingly gross problem. I don't even know like how I would start graphing this. I would try to find maybe some zeros, but it's hard. Luckily, the first one that they always give you, f of x, they will always graph for you. So f of x, that's graphing. That's what it looks like right down there. And we're going to let g of x equal that one. You always will have to graph the second one. You're going to be graphing g of x. Hopefully, you remember how to graph absolute value. X plus 2 plus 1. You remember how to do this, hopefully? We'll see. The graph of f of x, y equals f of x, is shown below. So f of x, there it is. If x1 and x2 are solutions, again, that's where the x coordinates of where the two graphs cross. And x1 is the smaller, x2 is the bigger. You guys need to estimate what is x2, what is the bigger intersection, what is the intersection farther to the right, and estimate within 0.5 units. So first step, graph g of x. We're going to graph the absolute value of x plus 2 and plus 1. So the parent function of absolute value of x, if you remember, is just a v. I can come over here for our notes. I can say our y equals absolute value of x. That's supposed to be an absolute value symbol. Looks like this. It's a v. The vertex is at the origin. It has a slope of 1 on the right, a slope of -1 on the left. So, okay, so we know what our parent function looks like. Then we're going to do what to it? When I have x plus 2, what does the plus 2 do? Yeah, Leo? Plus 2 on the outside would be up, I agree. But if it's on the inside, it's going to be either left or right. What do you mean by -2? Opposite, I agree. So what does that mean? 2 to the left or the right? To the left, exactly. So that means our vertex point, this point right here, is going to be shifted left 2. So let's go ahead and annotate kind of what Leo said. Right here, this x plus 2, that means left 2. Thank you. And then what about outside the absolute value? I already said it out loud. Plus 1, what does that mean? I know Leo knows it because he basically just said it. I want to call him someone new. Beverly? Up 1, there it is. And notice that the number out front, I didn't change that, so the slope has not changed. There's no vertical stretch or compression. So my vertex used to be at the origin 0, 0. But I'm going to go left 2, up 1. So my original points, these were the original points right here. That would have made, and you don't have to draw this in your notes, that would have made this graph right here. But we are going to go left 2, up 1 for both of these points. So left 2, left 2, up 1. There's our new vertex. Left 2, up 1. There's our new second point, and I can delete those original points. And I go ahead and make my graph. And I have a line tool, I should use it. And so it looks like this. All right, so we have our graph, but now we need to answer the question. The question was asking, hey, this graph intersects this red graph 2 times. It has an x1, x sub 1, x sub 2. X sub 1 is right there. Roughly, I don't know, negative 0.75, comma 2.3-ish. But we don't care about x1. We want to know the value of x2. X2 is this other intersection. Can someone estimate the x coordinate of this intersection up here? Someone that hasn't spoken? What is the x coordinate of this intersection up here? Yeah, I'll show you. 6, there it is. The answer here is 6. Why? Because if you look down, this x coordinate is 6. And we're done. So again, the process for each of these is graph it, find the x coordinate of the intersection, move on. We're moving on. Here we go. Example number 3. We have a really gross function for e to the 0.5x minus 3, which is graphed down here. You guys are responsible for graphing this scary thing, 2/3 x minus 1. Prove to me that I taught you something in algebra 1, right? Graph 2/3 x minus 1 right now. Everyone should be able to do it, at least sketch it on your own. Again, each of these problems is telling you to sketch it. You don't need to have a ruler exactly. Everyone right now sketch 2/3 x minus 1. Oh no. The y-intercept, this is in slope-intercept form, the y-intercept is -1. -1 is one of the first points, right? This is a line. So everyone has -1. That's our first point. Next, we're using the slope. Rise or run. Change the y over change in x. Up and down versus left and right. Find another point. Go right 3, up 2. From this point, our y-intercept, right 3, up 2. Go to 3, 1. That's our next point. And make a line that goes through those points. And then read the question carefully, because sometimes they switch the order of which one is the bigger, which one is the smaller. This one I didn't change, I just copied and pasted it. So x2 is the bigger one, and we're trying to find x2. So find the one that's farthest to the right. Estimate again to the nearest 0.5. Who can estimate the x coordinate of not the first intersection, but the second intersection? What is that roughly? The x coordinate. Come on, guys. I'm not going to call on Hillary or Beverly because they obviously know what they're doing. Go on to the next problem, Jules. What is the x coordinate of that intersection? Oh, so go for it. There it is, 6.5. If you look and drop the point down, it's roughly at 6.5. I'll leave that line on here too. The answer here is 6.5. And our final example, example number 4. We have a hard kind of gross function, a negative natural log of 2x minus 3, which is graphless. Yes. You guys need a graph, -2 times y of x minus 4 20 squared plus 2. So that's going to be a parabola. It's a quadratic function. Same instructions. Notice that x1 is the smaller one, x2 is the bigger one. Again, estimate the x2, the farthest to the right intersection, by the nearest 0.5. So everyone right now, graph this. The parent function is a parabola. I can come off to the left here and say our parent function y is equal to x squared is just a parabola, where our points were at the origin and one right, one up. So if I were to rewrite this problem, -2 in parentheses x minus 4 20 squared plus 2, what do each of these numbers do? Can someone tell me, what does -2 do? What does -4 do? What does +2 do? Yeah, Leo. Which one? +2, do you say go up? That's correct, yeah. Up 2. Nice. Someone else. What does the -4 mean? I think you'd know, Leo, so you can kind of just write it down if you want. I want to see someone else. -4. Anyone aside from Leo? What does the -4 mean? Oscar, yeah. Yeah, so you want to think of opposite, yeah. So what does that mean though? Up, down, left, right? Stretch, I don't know. Yep, means right forward. And then finally, this is probably the hardest piece. What does that -2 mean? Someone aside from Oscar, someone aside from Leo. And I will give that to us because I know that one is a little bit harder. Technically, there's two parts. The negative here means flip. I can't spell flip, upside down. And the 2 means stretch it. That's a vertical, I can't spell, that's a vertical stretch by a factor of 2. So if I were to come back here and the original problem would have the vertex at the origin 0, 0, and it would have another point at 1, 1, and it would be this parabola shape. Is everyone okay with the parent function? Now I'm going to move those 2 points right 4. That's the first step. So right 4 means 1, 2, 3, 4. My new point is going to be right here. 1, 2, 3, 4. My new point is going to be right here. And I can get rid of those old points. That was the first step. The next step is I need to not move the vertex. This -2 right here only changes this second point. That first point, that vertex, does not get changed by that scaling factor. What is the height of my second point going to be? What is the y coordinate of my second point? And if you don't know, look at your notes from yesterday. This is exactly from yesterday. What is the height of this second point going to be after I multiply by -2? It used to be 1. 1 times -2. -2. So this height used to be 1, and now it's going to be down here at -2. And then finally, the last step, +2. Leo told us up 2. So I'm going to shift both these points up 2, 1, 2, and I have my final resting spot. Remember that our vertex was this point that's up above. So I used to have this point, I go up 2, and it comes up to this spot right here. This point goes up 2, 1, 2, and I can get rid of this old one. Again, remember that this one is your vertex, which means the turnaround point in my parabola is upside down. Why? Because I have a negative value up here. and I come down through here. And again, it's just a sketch. And we don't need anything really more than that because we can probably estimate where that intersection is. All right, someone aside from Oscar, who did the last two, give me the exponent of that intersection, the second intersection. Caroline, go for it. There it is. Our answer here is 5.5. And that concludes the notes. All right, give me a list of 5. How well do you think you can do all of today's homework? 3, 4, 2, 4, 3, 4, 5. 5-ish, 3-ish, and Leo's at a 4. Okay. Well, thank you guys.